All right, class. We are going to be trying something a little different today. And I need you to have your 3.4 extension notes out. We're going to go ahead and take each example one at a time, and you're just going to hear my voice and see my example just as if I were right here in front of you. So today we're going to be talking about factoring an expression. And when we do talk about factoring an expression, we are actually just undoing the distributive property, which is what we did yesterday. So remember, think back to yesterday, we had our present, and we distributed that present to everything inside the parentheses because outside the parentheses was multiplication and inside the parentheses was addition and or subtraction. And so we were distributing everything inside the parentheses. Okay? So we're going to start out by writing our definition, and we are going to be looking at factoring an expression. Factoring an expression is just undoing the distributive property. Okay, so we're undoing the distributive property, or it also means, oh, there goes the black and red again. Or it means writing an expression as a product of factors. Okay? If we're writing an expression as a product of factors. Okay, so we're going to go ahead and we're going to look at the tip that we have here. When you're factoring an expression, you can factor out any common factor. All right. Hold on one second here. I think I'm going to pause this. All right, sorry about that. That was just a pause. All right, so we're going to continue on with factoring an expression. So basically, like we said before, we're just undoing the the distributive property. And if you look to the right side of the smartboard, you will see a poster that talks about happy birthday factoring. And this is basically what you're doing, is we multiplied everything in with the distributive property, but when you undo it, the opposite of multiplying would be to divide. So we're going to actually just be kind of creating a layered cake. And if you notice, each layer of cake kind of looks like a division sign. Okay, so we're dividing a number that both terms in the parentheses, or in the, excuse me, not in the parentheses, but in the expression they have in common. Okay, so our first example we're going to be asked for is that we're going to ask to factor 20 plus 8 using the GCF. I hope everybody remembers GCF is the greatest common factor. And when we're finding the greatest common factor, we're finding the largest number that goes into both numbers. Okay? And when you use the happy birthday factoring, you don't even have to know what the greatest common factor is between these numbers. So what I'm going to do is I'm going to start by writing my problem, which is 20 plus 8, down below. That's my first layer of cake. Some cakes will have multiple layers, some will only have one. And then I'm going to make my first layer of cake, which again looks like a big division sign. Excuse me. That is what we are doing. We're dividing. So we're looking at 20 plus 8, and we're saying, okay, what factor is in both 20 and 8? And a lot of us are going to say, oh, they're both even, so I know 2 goes into both 20 and 8. And that's totally fine. It may not be the greatest common factor, but it is a common factor. Okay? So I'm going to go ahead and take the 2 that I know goes into both of these and put it outside and divide both those terms by 2. So then I do 20 divided by 2, and I get 10, and I put it right above. I have an addition sign right here, so I'm going to bring that addition sign above. And then I do 8 divided by 2, and I get 4. Okay? Now I look at my 2 numbers on top of the line. Do I have any other factor that goes into both 10 and 4? And I notice that they are both even again, which means I can take another division sign or make another layer of cake. And I know that 2 goes into both 10 and 4. So now I'm going to do the same thing I did with the first layer and say 10 divided by 2, and I get 5. I bring up the addition sign, and I go 4 is divided by 2 is 2, and now I have 5 plus 2. And now I ask myself, is there any other factor that goes into both 5 and 2? And I notice that there isn't. Okay? So 5 and 2 is going to be what's in my parentheses. That's the sum inside the parentheses that I originally started with before I used the distributive property to get 20 plus 8. The number outside the parentheses is going to be whatever is outside whatever I divided them both by. If I have one number, then I bring that one number up. If I have 2 numbers, then I multiply them together. So I took out a 2, and then I took out another 2, which means 2 times 2 is 4. So 4 is the number that will be distributed inside the parentheses if I wanted to use the distributive property. Or 4 is essentially our present. So I factored 20 plus 8, and I got 4 times the quantity, 5 plus 2. That is my answer. That is in factored form. I have written my expression as a product of factors. Product means there's multiplication. 4 is being multiplied by 5 plus 2. Okay? Now, what happens if I wouldn't have taken 2 out? What happens if I would have started my problem at 20 plus 8, and I took that and made it my cake layer and noticed that 4 goes into both 20 and 8. If I noticed that right away and divided both of them by 4, 20 divided by 4 is 5. Bring up the plus sign. 8 divided by 4 is 2. So I have 5 plus 2. I notice, is there any number that goes into 5 and 2? No. So I put parentheses around 5 plus 2. Whatever numbers are on the side, I only have 1, so I just bring it straight up. That's the number in front of the parentheses, or the present. And notice that 4 times the quantity, 5 plus 2, is the exact same thing that I got when I took out 2 twice. Okay? I factored. It doesn't matter whether you take the greatest common factor out right away or whether you take a couple common factors until you have nothing left to take out. Okay?